I need to shut down the video project.
Yeah, okay.
I'll be back in a moment.
Oh, okay.
Yeah, I can.
David is here for 12 years at Elastic. So when he comes in, I want to say thank you and everything. So, yay! So before you do it,
You did that?
I did that.
Okay.
So David, so when we started Elastic, first of all, we presented in What's Next, and that was before you joined us.
Yes, I was there.
You were there. And What's Next was one of my favorite conferences in Europe. So if you plan to bring it back, I'll be the first speaker to line up. It was a great conference. I remember being very nervous because I did like 30 minutes only hands-on demo, and it's like curl requests and things like that. And I think very quickly afterwards we started the company, and I asked David if he will be willing to join us in another conference. And David now is in Elastic for 12 years and has been an amazing force in our community effort, in our open source ethos, in managing the community and helping the community in France and worldwide. So thank you very much, David. And obviously a good friend. So, yeah. Still friends.
I don't have a mic, so I have to So there is a Ask Me Anything section?
Yes, let's do it.
There were some questions.
Yeah. So I'll start with maybe just giving a bit of background. My name is Shay Banon. I wrote the first few lines of code of Elasticsearch and open sourced it in 2010. One of the founders of Elastic in 2012. I was the CTO of the company, Chief Technology Officer, when we started. I got demoted to be a CEO for a few years, and now I'm back to be a CTO for 2 years now or something like that. Right around the time that, so I moved back to be a CTO because I really wanted to go back and focus on technology and be a bit more in control of my time. When you're a CEO of a public company and things like that, a lot of people control your time versus you control your time. And one of the other things that I really wanted to do was try to drive some big technological product shifts within Elastic. And the first one that we were pushing for was something that we call a stateless architecture of Elasticsearch. And I think it was 2 years ago or something like that when we had a meetup here, and we spoke about like two big projects that we're doing at Elastic. The first one was the stateless architecture of Elasticsearch that I presented, and the second one was ESQL, Elasticsearch Query Language. And it's funny to reflect on how much progress we made over the last 2 years. The serverless architecture, it ties into this question, so I'm giving a bit of background. The serverless architecture of Elasticsearch is a big part of it from a product perspective is this stateless architecture of Elasticsearch. And the stateless architecture of Elasticsearch does a lot of things, but one of the big aspects of it is to decouple compute and storage. So when you index data, it gets indexed on specific resources, and when you go and search, it searches on different nodes. The indexing and search is completely decoupled. Computed storage is decoupled, so the main storage of Elasticsearch is on something like S3, so like a blob store, if that makes sense, obviously in different cloud providers. And it's really driven by, this is like more of the typical like more new age cloud native, if you will, type of architectures that you have in the system. It's been a lot. This is the biggest project that we've done at Elastic since we started. Not only the stateless Elasticsearch architecture, but also using it to provide our serverless offering. So the serverless offering of Elastic on our cloud is based on this like stateless architecture of Elasticsearch. And beyond just the changes in the product and how they work, it's also, for example, a completely fully managed offering. So it is a serverless offering. We try to like go and say, we'll take care of most of your asks, sharding, partitioning, auto-scaling, all of these things. So it's like it's a serverless data store, if you will, architecture versus our existing like cloud infrastructure we called hosted, that it's kind of like our responsibility and your responsibility is kind of like 50-50, right? So you're still in control of sharding and scaling and more in control about how to deploy resources and infrastructure. And in the serverless stuff that is based on this stateless architecture, we are more in control of it, and we kind of like, mostly our vision is, here's some APIs, just push data into Elastic, query it, open Kibana in front of it, and you don't have to worry about anything else. We've started to roll out our serverless architecture. It's provided on AWS to begin with. Azure and Google Cloud are going to happen very, very soon. And we will also deploy it across the globe. So we started with a few regions in AWS, but we will increase the amount of regions and footprint that we have, obviously, in Europe and in Asia and in other places. So we're rolling it out. It's a huge, huge change. Production ready, so you can go and start to use it. Still missing a few features. For example, the ability to do cross-cluster search between serverless projects. That's something that we're working on as we speak. But if you don't need these features, we have a whole page that lists those features, then you can go and start to use it today. Okay, so I said all of that. Now there's a very good question that, by the way, we're asking internally. Stateless Elasticsearch, this like architectural change that we've done, is this something that we can also bring to on-prem? So for customers that have to run on their own servers or things along those lines, or is it only going to remain on cloud? I think that question was also asked 2 years ago, which is a very good question, by the way. I'll start with saying about our strategy at Elastic. Our strategy at Elastic is to have parity. So everything in self-managed also happened on cloud. We have very strategic customers that can only run on-prem. In France, in UK, in the US, and they will not run on the cloud, which is okay for their own reasons. And our strategy as a company is to embrace these customers, and we think we provide a lot of value as a company that provide products both for self-managed or on-prem and on the cloud. So we work and try really hard to ship everything that we can to self-manage next to the cloud. So we're not one of those companies that says, okay, we'll ship only some features on-prem and try to use the lack of these features to get you to go to cloud or something like that. So if that's our strategy, why don't we have stateless Elasticsearch on-prem? And the reason is that stateless Elasticsearch significantly relies on advanced semantics, how things work of the blob store that it works again. S3 on AWS, Azure Blob Store, and GCP Blob Store. It's also called, so it really heavily relies on the semantic of it. We had a previous feature that we have. It's not a previous. It's still working. That allows you to work on top of blob stores or binary storage systems. It's called searchable snapshots. And that one we allow you to run on-prem. The requirements of searchable snapshots are very, very limited from S3. It's mostly just to be able to go and read the data. When it comes to, and write it in a very simplified way. When it comes to our stateless architecture, we use much more advanced semantics of the blob store itself. Our experience with customers using searchable snapshots on-prem and on-prem storage providers is very bad. I won't name names, but it's very bad in terms of companies and storage providers saying we are compatible with S3, but they're not really compatible with S3. And we've been, our searchable snapshots implementation has a lot of workarounds around many of these companies' deficiencies and how they work. Now think about that part and like 5x it, and that's the semantics that we use for using stateless Elasticsearch. Remember, stateless Elasticsearch, it's not only to search data, we basically allow you, it's like, if you think about it, it's like a writable frozen tier, right? So it's like, we allow you to both write and read the data from S3. S3 becomes the main storage of the data. We ship the transaction log of Elasticsearch through S3 to save costs when we can. There's like a lot of semantics. We do discovery through S3 in a much more advanced way. So there's many more requirements that we have from this system, from S3. We rolled it out, when we rolled it out to AWS, we went and we found, I think, a couple of bugs on, for example, Azure Blob Store that delayed us from the ability to roll it out on Azure. And we worked with Microsoft to fix the Azure Blob Store API semantics to make sure that we can go and implement this implementation on top of it. Now you'll ask, by the way, one of the things that you can ask is, well, why are you so special? Or why do you need this like special semantics or things like that from S3? The reason is that I think we're the first search engine that decouples storage from compute. The requirements that we have from it is very different than like a columnar storage, like a Cassandra or ClickHouse or something like that. It's very, very similar to try to decouple compute and storage for a relational database, which is really, really hard. But it's like it's extremely difficult to do that because of the semantics of APIs and how the system work, and we've managed to do it. But as a result of it, we ask more of the blob store as well. We take a lot ourselves, but we ask more of the blob store. Anyhow, that's a very long story, but today, at least, we want to battle test. So we want to like make sure that our implementation is good against Azure Blob Store, Azure and GCP before we think about anything else. So to be honest, like we said, can we provide it on-prem? Can we not provide it on-prem? But we ask these questions internally, but we've pushed it out a bit, because we want to deploy at the very least, at least across these 3 cloud providers and make sure that the implementation works well. And even deploying across the 3 providers is proving to be difficult because of this like change in semantics. So we work now really hard just to support these 3 cloud providers. Maybe as a result of it, by the way, it makes our implementation stronger. Now in the future, I'll tell you my personal preference, I want to ship it on-prem. I think it's a wonderful architecture. I think we have very important and interesting implementation on-prem. So like I go to these discussions wanting to ship it on-prem, but we need to understand what's the cost of us shipping it on-prem, and does it mean that it will cause us to move significantly slower on cloud as a result of it. I think we also need to learn a bit from our searchable snapshots implementation. For example, we really struggle. Like we would go in and a company will go, I bought X amount of data from this vendor. They say that there's S3 compatible API. It's your problem. Like it's Elastic problem. It's your fault. By the way, when kind of like we go and say like, it works against S3 on the cloud. So why does it, like you say it's S3 compatible. So it caused some friction between us and our customers. Because they were like, the customers would say, hey, like it's searchable snapshot. I spent so much money buying all of this like local storage for like blob store, and now you're saying that it doesn't work on it. So I think we need to learn from it. By the way, being very, very transparent and open here, my idea at this point is to create like a certification, something that you run, that is completely open. It just goes and says, these are the features that we need. You run it, you get like green, red on each capability that we need. It's very open, very public. And then we go, here's the, it's not about whether searchable snapshots work or something like that, or stateless Elasticsearch works. It's like, here's the certification. You run it against EMC, pure storage, mean IO, backed with whatever. And then if it works, it works. And we stand behind it. But we need to do something slightly different, I think, compared to what we've done before because of the challenges around it. That was a long answer, but like hopefully it makes sense. Yeah. Oh, okay. So when will Resource Manager to limit ESQL consumption of infrastructure, for example, by client be available? So again, I'll give a longer answer because this is the trick with Meetup. Someone comes to the Meetup and say like, this is a specific feature that I want, and I want everybody to be interested around just trying to understand how we're thinking about things and what we're building. So I spoke about stateless Elasticsearch 2 years ago, and Adrian was presenting ESQL, Elasticsearch Query Language, which is another huge project that we have at Elastic, the Elasticsearch Query Language. Obviously, we're very bad at naming, so we called it ESQL, and people think that we implemented another SQL language on top of Elastic. But there's the line here, so hopefully it helps, but I don't know. And by the way, we call it the Elasticsearch Query Language. So one of the nice things in this like what's next presentation that I did that was great about Elastic 12 years ago or 15 years ago, whatever, was like these JSON APIs, and it's easy to use, and JSON documents and what have you. The world has progressed since then. And some would say a bit digressed as well, but who knows? And there's a better ways to try to query data and munch it, if that makes sense. And you would see sometimes users writing queries against Elastic, and they're like big JSON trees and the complexity and things along those lines to do something simpler. So we looked around and inspired a lot also by our competitors. For example, Splunk, that has a pipe-based query language. And we saw that it's actually pretty cool as a pipe-based query language. Pipe-based query language is like you write a statement, and then you pipe it into another one, and then you pipe it into another one. But it's like old school Unix, if you will, pipe-based language. And it's very empowering, like, because you can give it to less sophisticated users that know your query language, and it's kind of like understandable. It's text-based, and you can look at it and understand what happens and things like that. So we went into the process of writing Elasticsearch query language. This is, again, a big change in Elasticsearch, because Elasticsearch it's very powerful in terms of how you can do queries, but at the end, most of the queries are done very close to the data on the shard level. So there's like Lucene ++ type of queries, if that makes sense. There's not a lot of a query engine smartness in the execution of Elasticsearch. And this is the first time that we're introducing an actual query engine in Elasticsearch. So we build a whole new query engine that knows to take the query, builds a query plan, and try to figure out how to execute this pipe-based execution. It's the foundation to support joins. That is like one of the, whatever we say, it, like people get excited because everybody wants to do joins in Elastic, in Elasticsearch. So it's really the foundation to be able to provide a lot of advanced capabilities in Elastic. By the way, one of the interesting challenges of pipe-based language is search. It's not very obvious. How do you add search capabilities to pipe-based language? How do you think about scoring? How do you do like retrieval-like operations, things along those lines? I mean, simple search are fine, but it's not straightforward. We're working on it, and I'm happy to share some of it. So ESQL is out. It's running. It's in the open. By the way, you can go and use it now, and it's in the obviously open source or free version of Elasticsearch. You can go and start to use it. And yeah, specifically on this one, I don't have an answer. I don't know. I'll start with saying there's a clear need for this, right? So it's like the ability to go and say, well, I want to be able to segment API endpoints or segment type of users or something like that, and say these ones are more important than others and what have you, and things along those lines. This is a very tough one to go and implement, to be completely frank with you, in data stores specifically. Like, how do you count? How do you slice? How do you do resource allocation in a system like that, in a distributed system? But I can tell you that we want to go and solve this, at least in ESQL today. For the next 6 to 9 months, we still have a lot to do before we get to here. So we're implementing the first phase of joins in lookup joins. We're introducing scoring and search into it. we just came up with a really cool way to try to implement retriever-like semantics for Gen AI. It's like forked execution within it. That's hopefully will come in the next couple of months. So there's still a lot of work, just like working on the basics before we get to this type of resource management. So the typical hacks to work around it still apply with Elastic for the past 4 years, if that makes sense. Okay. Why logsdb is available on Enterprise Edition only? So first of all, I'll start with saying, have you heard that we're back to be open source? So yeah, by the way, I'm very happy. One of the happiest moments that I've had in Elastic history was the day that we said that we went back to be open source. It was very painful for us, a very painful decision. I wrote about it in a blog post. If you haven't had a chance to read it, it was a very, very painful decision to move away from open source. And we felt like we were forced to do it due to Amazon Elasticsearch offering shenanigans. And after a few years, we felt like we can go back to be open source. I mention it because we work really hard to provide a significant portion of our capabilities in open source in free. ESQL is free. Most of our work, a vast majority of our work in generative AI is free. Our goal is to make Apache Lucene the best vector database, not even Elasticsearch. Now, there's things that you can't do in Lucene, so I think the combination of Elasticsearch and Apache Lucene makes it into the best vector database in the world, or we're working towards making it the best vector database in the world. I think we're up there. But a lot of these capabilities are in the open and free. Now, we worked on a lot of different features, but one of the things that we worked on was we asked ourselves, hey, we kind of like a document database, right? So it's like we take JSON documents, we store them using Apache Lucene. We take the data, we index it in many different ways. Some of it is an inverted index, some of it is in columnar type of index, some of it in other ways. And we said for logs, there's different ways that we can work to try to reduce the storage of logs, right? Because the more logs you have, I think the better system you can have. I can talk about logs for ages. By the way, the last 6 months, I spent a lot of time on Gen AI that I'd love to talk about, by the way. I think this is a huge change if someone is interested in the world. But actually, the last 4 or 5 months, I spent a lot of time just working on logs because I'm really excited about what we can do with logs in the future. Anyhow, we looked at all of these capabilities. We provide so much ESQL. Our logs users love it, right? Like you can go and take and use our free version and start to display Splunk more easily, for example, if you want to. So like tons of value that I think we continuously provide in our free version, in our open source version, and we continue to provide it. Now, we looked at the storage aspect and we say, okay, like we want to have like a bit of intensity towards reducing the cost of storage in logs. That's always good. You know, some things are relatively straightforward. Sort the data based on timestamp, things along those lines, and all of these things, you know, we ship them in this like logsdb mode, and it's free, and you can go and use it. There's one really beefy feature. It took us about 1.5 years to work on it. And it's like saying, okay, sometimes like for logs, actually using a document database to store logs, it's not the best in terms of storage. So maybe we kind of like, we can fake it. Maybe we can take the logs or the documents, and because we know it's logs and it doesn't have all the requirements that they are, and we kind of like fake it and we'll store it in a columnar storage mode instead of storing it as a document mode. So we work on this capability. A lot of the work went into faking it, right? So it's like still storing it in that specific way and then still providing the same API, the same semantics, the same capabilities on top of it. And this doesn't change the behavior of like the query capabilities, the everything. It just reduces the storage that logs take. And we felt, at least for this one, that it makes sense to make it into an enterprise capability. Obviously, this helps reduce the cost of storing your logs, and that's like a big value that we provide to you that we think made sense for us to provide it as a paid feature. Again, like this is broken down into 2 different modes. Some of it is free, and the big chunk of like the columnar storage that took us a lot of work, we felt that it made sense for us to provide it as a as a paid feature on our cloud and on-prem. So if you go to our cloud, it's an enterprise subscription. On-prem, obviously, it's an enterprise subscription. Tends to apply mostly to our very large customers, so people that stores petabytes of data in Elastic. If you're storing petabytes of data in Elastic, you probably want to be on our enterprise subscription regardless. You're going to save a lot of money with searchable snapshots, with other stuff. So we felt like that's already like a lot of value that we provide to you on that level. By the way, to complete the picture, maybe connected to the first question, if you go to serverless, to our serverless offering, we have a different pricing model or a different way to work, and then that's less relevant. So like you're benefiting from it inherently out of these capabilities, at least for security and observability. That's it. There's tons, by the way, of other things that we're working that hopefully will make logging significantly pleasant and enjoyable for our users to use. I mentioned ESQL as a way to explore the data. I'm talking a bit about where we're heading as a company and areas that we're investing. We want to make Discover fun to use. And you know, it's kind of like became old, and I think you saw some of the UI here in the demo, and I was like, yeah, it can be nicer. So we're working a lot on making it nicer. A lot of it revolves around ESQL and the experience that you would have with ESQL. We said like, do you know Notion? Notion is like a text editor. It's like, it's really well designed, have a really nice UX. So we want to make like Notion-like editor for ESQL, and Discover renders itself really nice. We're investing heavily in dashboards. Again, make them faster, collapsible panel, using variables in ESQL to introduce variables to all of these, to dashboards. So this is like the areas that you know, it's funny when sometimes you work in products like, and you exist for now, so long, and it's like sometimes you run and you want to implement like the new stuff. It's like stateless aggregation, things along those lines. Sometimes you forget the basics. It's like dashboards should load fast. You know, it's like variables in dashboard. You're like, no, we have this new thing. We want to go, yeah. You're like, no, remember, this dashboard still need to load fast. Discover as an experience that our users spend in Discover so many hours finding threats or finding why things break. Like that's an area that users need to love and enjoy using. So like we're also actually going back a bit to the basics and trying to like make things foundational and enjoyable for you to use. So there's tons and tons of investments in all of these areas. Again, like most of them are in the open, most of them are free. Our strategy, by the way, and my personal strategy when it comes to trying to get people or to get customers, especially in self-managed. In cloud, obviously, it's easier because in cloud, you always pay, right? Like you don't expect to get free cloud. But especially on self-managed, our strategy is not to go and like, here's 1,000 features and 326 of them are paid or something like that. But to find like 2, 3, 4 really beefy features that tends to also correlate with customers that use us for mission critical, really enterprise workload that aligns with the fact that anyhow they would have paid for, you know, they would have become a customer of ours. They would not have used only open source, if that makes sense. And we felt that that was one of them. Okay. Does quantification of vectors impact precision? I love, this is like always in these meetings, in these meetups. Like, I'll take a step back. How many people here heard about Gen AI? How many companies added AI to their name? I'm joking. So I've been around for a few years in the technology space, and I can honestly tell you that what happened a year and a half, a year ago, I don't know, time flies, it feels like 10 years, but it's groundbreaking, and it's going to change significantly how we're going to build software and how we're going to use and engage with software. And I know there's like people going, oh, we don't think so, LLMs hallucinate, and you know, it tends to find like the small reasons why it won't, enterprise will never adopt it, whatever. But really, it's like, it's enough to look at your kids doing homework with ChatGPT to understand that the world changed. And by the way, the way that I design, I'm thinking about like at least a quarter of the features at Elastic is watching my kids using ChatGPT to do homework, and I go, oh, we can use that for logs. And it's amazing because there's like a innocence of using products, and they don't come with like the baggage of society and will there be work and questions that we should be answering. And they go, this is a freaking amazing tool, and it is amazing. So things change, and we need to ask ourselves, how is it going to change it, and how are we going to build software as a result of it? How are we going to build software in different ways? How it's going to, and obviously things that are outside of our control, like society and others, happy to talk about them over beers or wine or whatever. But anyhow, so Gen AI changed a lot of things. And if you're building software today as a consultancy, as a product company, it doesn't matter. If you're not thinking about what does it mean to the product that you're going to build, someone else is going to do it, and their product are probably going to be significantly better than yours. So you should be doing it, and you should be thinking about what does it mean. And I'll give you a few examples of where like this type of engagement work and how do they make a difference. We at Elastic took all of our support cases. So the most basic way, the most popular implementation, type of implementation of Gen AI today in companies is customer support. And the reason is that, and I'm not talking about like, we'll just put a chat system in front of our customers and say that we're Gen AI, right? Like that's silly. And most of these chat systems are not very good. But it's about getting your support team, internal, external, for your product, it doesn't matter. But instead of using Google or search or something like that, or going and finding on the web and what have you, like try to take the internal information that they have, the support cases and all of these things, and use LLMs or ChatGPT to try to help them. So when they ask a question, now suddenly you can take all the private data that they have, access to the cases, access to all the history that they have, munge it together, and being able to use an LLM together with it to help them solve support cases faster. That has proven to be very, very popular. And if you're not doing it today in your company, you probably have support in your company, like someone supporting someone in your company. Then try to figure out how to do it, because it makes a big difference for us. I don't remember, what's the case handling time for us? It's like we're like 5x faster. Our support team is 5x more efficient. And it's like someone asks a question, obviously they know a lot about Elasticsearch, but there's all the documentation on the web, and they need to go and Google it, and is it in the last version or the new version? And was there other customers that mentioned this problem, and was it mentioned in the release note? It's like, there's a lot of questions that you're asking yourself, but if you express it in a simple question, and you use an LLM together with your private data, like suddenly something that took you 15 minutes to do takes you a minute to do, which is a big difference, right? Like my kids, used to take them 15 minutes to do homework, and they do homework in a minute now. So homework needs to change. It's like there's no, like you need to ask different questions. But that's exactly what happens in our customer support organization, and that's what will probably happen in yours. That process is called RAG, Retrieval Augmented Generation. I hate that name. I don't know who came up with it. We'll use it. It doesn't matter. But basically what it says is LLMs, the way that I'm trying to think about LLMs is that they're very intelligent, but they're not very smart. So it's like highly intelligent. It's like someone sat there, read all the internet, and knows how to connect the dots and give you information, but they're not smart. Smart comes from like wisdom, or comes from experience, and experience is your private data that you have in the system, right? It's like in an organization. That's the experience that you built over years. It's the knowledge bases that you wrote, it's the cases that you manage, it's other stuff that you do. And I think when you combine the two together, magic happens. And that's basically RAG. Take all of your private information, try to put it in a system, and I'll talk about that system in a second, and then do this RAG workflow. Someone asks a question, go to the private data, search it in a natural language way, extract the cases that are relevant, extract the bits of information that are relevant to that question, and then use it as context to the LLM. Go to the LLM and say, here's the question that was asked, answer this question, but here's additional context that makes you smarter, not only intelligence, if that makes sense. Now, why does it work for homework and you don't need private data? Because in homework, everything is public data. So the LLMs were trained on it. Hopefully, the LLMs are not trained on your private data. Hopefully, the LLMs are not trained on your company's private data. And hopefully, you're not trying to build an LLM trained on your private data, because please don't do it. It's very expensive, and it's a waste of time. Like this space is moving extremely fast. Don't spend time trying to figure out how to build models. Try to figure out how to use models. That's like much better within your enterprise if you're thinking about like a strategy for you. So you want to take all this big private data, put it in a system, and then feed it into the LLM. That workflow, it's called RAG, and you can think about applying it to many different cases, right? Like customer support, I don't know, Baha, how many do we see these things all the time. Now, what is that system that you put your private data into? That system, I mean, there were a lot of theories a year and a half ago. At one point, that system was only a vector database. And there was like Elasticsearch is dead, or text-based systems are dead, vector databases are the only future, things along those lines. I think if you fast forward to, or for example, another one was, well, anybody can add vector database as a feature, like MongoDB or others, and things along those lines. I think if you ask most people today, they realize that really the use case for these private systems is search. It's back to old school search. What does search do? Natural language, type in a question, type in something, find the most relevant information, in this case, the most relevant bits of context that you have in your private data, give it to the LLM, and have that workflow. So people realizing that search system from, I don't know, most open source projects like LangChain and DeepSet and others, they're all like, search is the most popular integration for this type of use cases. What they're realizing is that vector databases are amazing. And we're trying to build the best vector database in the world. Forget about text-based search, BM25, forget about columnar filtering or something like that. We're trying to build the best vector database in the world in Elastic. But also vector databases are not enough. You need to have hybrid search. People are still trying to do direct lookup, like direct hits. They know what they're searching for, together with like natural language questions. You need to be able to do filtering. You need to be able to filter your private data, attribute-based searches, filters, geo-based searches, things along those lines, to be able to do it in the right way. Actually, the hybrid search story is a very interesting one, and that's probably what's going to be most relevant in this case. That's what we're also very focused to build at Elastic. So for example, the way that we implemented vector database at Elastic and in Lucene is in a way that it works with all the other features. So you can do a geo-bounding box to search and do vector search within it. And that's like, when you say that to pure vector databases, they can't do these type of things, for example. So that's like extremely capable. And again, like if you're not experimenting with vector search, you're here because you're using Elasticsearch. And you're here because you're using Elasticsearch either for pure search or for observability and security. And I'll touch on observability and security in a second. I don't know how much time do I have. That's probably going to be the last answer. I'll get to this question, but I really want I want to share what I see in the industry and what's going on versus like a specific capability. Those, you don't need me to answer this question. You know, there's Jim is here, smarter people than me to answer this question. Where was I? Okay, so hybrid search, vector databases. You want to be able to go and, you know, if you're interested in search, really start to experiment with vector databases. The way that I like to think about it, obviously, I'm making broad statements. Everybody can poke hole at that statement. I can. But generally, the way that I think about it when I try to simplify it is like search got 10x better suddenly, one day. It's not one day. We've had HSNW before, ChatGPT, but it's like it feels like one day search woke up and it got 10x better thanks to vector search. Now, obviously, it's not really always 10x better. It doesn't answer well BM25 type questions, things on those lines, but it's suddenly significantly more capable. You can do semantic search. You can do these type of things that wasn't very simple before. In the last year, there has been incredible progress in this space. And you should be experimenting with it, even if you're not using a large language model. So even if you don't have access to an LLM, even if you can't use an LLM because of company policies or valid questions around what was it trained on and things like that, just think about how do I introduce vector search to search experiences to my users? And is that maybe significantly improve their life? And we've had many customers that just did that, and it's blown away some of the things that they're doing in terms of capabilities. Now, in order to use a vector database, what does it mean to use a vector database? If you take a piece of text, an old school search, still new school, still relevant school search, BM25, you take text, you break it into tokens with analyzers, you create an inverted index, and you can go and search it. And then there's like ways to do fuzzy searches and like things that are more interesting, maybe when it comes to searches that try to understand what you're doing, but that's the basic of it. On the other hand, vector databases, you take a piece of text, you analyze it, you just analyze it slightly differently. You go and you take a model, an embeddings model, it's called an embeddings model, to generate embeddings. It creates vectors. You put them in the vector database instead of this like inverted index, and you search on it. You do the same thing the way in and on the way out. And conceptually, that's very, very similar to search. And by the way, one of the things that we've really invested time at Elastic is to try to abstract away as much as possible the details. Because if you just heard what I said, it's kind of like the same in terms of workflows. So we have a field type in Elastic in the mappings called text, that you take the text, we break it down, if it's English or France or something like that, inverted index, and you can go and search. And now we have a field type called semantic text, and it does exactly the same thing, just happens to do it with a model instead of an analyzer. And when you go and search on it, it's magic behind the box, don't worry about it. We just now give you semantic search instead of like BM25 or regular classic text search. So I'm saying all of that because potentially your experimentation with this type of search should be significantly simpler with Elasticsearch. You just change text to semantic text. Now it'll come back to me and say, oh, great. Which model do you use? Which embeddings models? Can we control the model? How do we change it? Things on those lines. All valid questions. And this ties a bit into our strategy in this space. Our strategy is to be very, very open, but provide you good defaults out of the box. So we're not a model company, but we built a model. And we built a model called ELSER. Now, we don't sell models, but we built a model called ELSER, and we worked together with Microsoft to take another model called E5 to certify it, because we bundle it together with Elastic that you don't have to worry about it. Some companies sometimes, first of all, to provide good defaults out of the box. And the other one is some companies come to us and say, once I say model in my company, everybody like freaks out and asks questions about private data and things like that. Can you just treat it like a feature? You're not asking whether the English analyzer was trained on private data, or public data. or something like that. Or the Japanese analyzer was built on top of like public Japanese newspapers or private Japanese newspapers. So it's the same thing with these models. We'll take the responsibility as a company and tell you, don't worry, we have your back. They're like blessed, they're certified, just treat them as a feature. Now, we give you the points to integrate, and if you want to go and call an embeddings model that Mistral or OpenAI or Azure on Azure or Bedrock or whatever, it's just a small change in the mapping, in the configuration file. But other than that, like you pick and choose, but we'll also provide you a lot of these capabilities out of the box. So that's a bit about how maybe to go and get started with these type of things. To do a whole RAG workflow, I won't get into how to build it. It's simple and not simple. My biggest advice, always start simple if you can. So it's like semantic text the data, experiment with, I don't know how many people here are semantically indexing their data or experimenting with LLMs or models. That's great. That's great. Then run with it, and hopefully you'll see with what we're building that we'll have your back as you go and do it. Okay. Vector databases. So part of the process of vector databases is deciding how to take the embeddings and represent them as vectors and things on those lines, and how can you compress the data, because that can potentially take a lot of data, and that can potentially take a lot of resources in the system. So there's a whole process called quantization of vectors. But obviously, whenever you try to do optimizations, you might lose other stuff, right? So for example, if you optimize the storage that each vector takes, are you missing out on your ability to return relevant results? So is it like a knob? Like how much can we save on storage versus are we okay with the loss that we're getting for returning relevant results, precision, recall, things along those lines. It does impact it, but at least the algorithms that we provide out of the box impact it in a very insignificant way, and it's public on the website, on our blogs and in other places. But by the way, some of the things that we implement are like very common, right? It's like how you quantize from a 32-bit float into 8-bit float, right? It's like there's no magic there. You do the quantization, and we're using off-the-shelf algorithms. So it's like if you want to know how much you're going to lose, then go and read about it. My understanding is that up to 8-bit, Jim, it's a no-brainer, right? It's like 8-bit is a no-brainer. So if you're storing your vectors 32 bits or something like that, then go to 8-bit, and if someone asks you why, say Shay said it, and that's it. Beyond 8-bit, it becomes interesting, but the algorithms have improved so much, and the tests to validate it have also improved that I think it's perfectly fine to be more aggressive in terms of the quantization, either to 4-bit int many times, and also using another type of algorithm, the BBQ algorithm, that we developed at Elastic. So there's like a new algorithm called RabbitQ that was developed in Singapore, right, Jim? And we took it, we're working with them, but we implemented something slightly different, but kind of like the same, called BBQ. It's pretty crazy. It's like 32x memory improvement. By the way, that's in the open and free, so go and use it. And I think there's another one coming along that we were like, oh, but we can do better than this RabbitQ thingy, right? And how do we call it? OSQ? OSQ, okay. Naming, we'll see. But there's like a new algorithm. By the way, we have a blog called, a blog place called Search Labs. Go and read it. Our teams explain all the maths and everything that goes behind it and what we do. So there's another one coming along that I think still, it's like it's the same compression, but better relevancy, or... Yeah, better recall. Yeah. So it's better recall, even better recall than BBQ. That was already amazing for 30x compression. Like, you can kind of like go and say, well, BBQ, you should default to BBQ probably. Tomorrow, if you're not like very, very rigid about the level, like you really want to understand the level of recall that you have, and OSQ will provide you like even a better control on top of it. So that's like the low level stuff of vectors and implementation. That's really, if you're getting to the point where you're saying, I don't want to treat it as text, I really want to understand how vectors are stored, how they're being used. I want to control my my ranking. I really want to roll up my sleeve and start to figure out what's going on. I hope that most of you don't have to. So it's like one of the things that we're trying to do at Elastic is to keep it at a high level to say, we got your back. So it's like we'll change the implementation behind the scenes when we have a better one, and things will just work for you, so you can focus on the higher level aspects of your implementation.
I think we can take the last one, maybe. This one maybe.
Oh. It's not easy because I'm really bad with dates. So I never know when we do stuff. And by the way, one of the other things, at least for me, is that if we did something in the past, I completely forget about it because I only focus on what we're going to do in the future, which is also a very exhausting way to live, I would say. But what is 9? Eight. Yeah, hopefully next month or maybe in 2 months from now. I'm curious what someone is waiting on, because I'll tell you, a part of our strategy, at least at Elastic, again, with major versions, if that makes sense, most of the things that we put into Elastic, there won't be like a significant change in 9. You'll get most of the capabilities already in 8.18, 8.19, or something like that. Typically, our major versions follow the new major Lucene version. But it used to not come with a lot of features, but we kind of like build the foundation for the next set of features to come along, 9.1, 9.2, 9.3, and so on and so forth. By the way, big change in serverless. If you go to serverless, there's no versions. So if you go to serverless today and use it, you're actually already using Lucene 10. And you don't know it, because we already upgraded in serverless to Lucene 10 behind the scenes. So this is, it's been a big engineering feat for us to do all of these things behind the scenes without our users knowing that these things happen. But if you want to have access mostly to Lucene 10 capabilities, then version 9 is the one for you. Afterwards, 9.1, 9.2, 9.3, that's where you're probably going to start to see differentiation from the 8.18, 8.19 versions that are going to come along, and the rest of the stuff that we're building. If that makes sense.
I think we are running out of time.
Yeah.
Our meeting done. So thank you so much.
Yeah, thank you very much. Yeah.